Hello, Saline. Good
Hi.
evening.
Hi,
How
Mwangi.
are you?
Good,
Hi,
good.
Saline.
How are
I'm well.
you?
I am well. How are you?
I'm tired, Mwangi. It's been a long week,
Yeah, yeah. I
Been a
can
long
tell.
week being in the sun, doing things, but we thank God that it is the end of another working week
Yes.
for those who work until Friday, but for those of us who extend it every day up to Saturday, we are gearing up for the weekend. And so we are grateful that projects are moving on. Hello, viewers. I don't know if there are people online.
Yes, we are live, and we have already 10 people who have joined us, and
Oh,
numbers are going.
nice. Hi,
Yeah.
builders. How are you
Hello, guys.
doing?
Yeah,
So
it's
we hope
another great
you're
day.
well. It is another great day. It is like the first or second time that we're coming live with this baraza. And this is a group members where we share with you the latest technology. This is where we share with you deals in terms of sales and supplies. This is a group where we share with you how you can cost cut without compromising the integrity of your structures. This is where we discuss what you can access and what you cannot access in terms of technology, how to save money, which maneuvers to make without compromising the integrity of your project or of your structure. And obviously this evening we are coming to you live together with one of our friends in this group who have a very, very incredible product. We had promised earlier that we will be able to share with you this product or this solution that cuts your slab costs by 50%, if not more. And the reason we bring slab, why slab is important, perhaps Mwangi will be able to tell us, and why we are focusing on the slab particularly. So before we continue, perhaps I give this opportunity to Mwangi to say hello and introduce.
Yes.
Mwangi.
Hello. Yes. Hello, builders. I think this is another great day. It's been a while since we did a baraza in the evening. Mostly we've been doing videos live during the midday, during the hot sun. So today we are here seated, rested, and with one of our friends. So guys, today, as you've seen earlier, as Saline has had promised that we are bringing a new technology today that is actually cutting costs for you when you are doing slabs. So basically, whenever every homeowner, when they are building, there are usually 4 stages that are usually they need huge investment in terms of capital. You need to be prepared, and not only financially, psychologically, emotionally, because these stages make or break your dream as a homeowner. So usually these stages, we usually start with foundation. So of course, this is with the assumption that you've already acquired land and it's ready for you now to start building. So foundation is one of the key stages whereby homeowners, they spend a lot of money. The second stage is usually slabs. If your house design is a maisonette or it has a slab, then you have to spend quite some amount while building a slab. That stage is usually roofing. So roofing also is another part that usually you have to spend some quite good amount of money for you to do. The last stage is usually finishing, but this one is usually dependent on client preference. If you like executive finishes, if you like basic, or maybe you just want rustic finishes, you play around with them, the cost there usually is dependent. Today we are dwelling on one item among these 4, and this is the slab. So slab, every homeowner has to build a slab, be it the floor slab or a first floor slab. You have to actually build a floor. So the material that you use, the technology that you use, mostly is dependent on your know-how or your professionals, how far they are exposed, for them to be able to advise you which technology you should use. And today we are going to introduce to you a new way that is actually cutting costs than the conventional way. So we are used
Yeah,
to
Mwangi, correction. It's actually not new. It's new in Kenya, but it has been used for
yes,
years in the world.
absolutely. I mean, new in the context of the Kenyan construction industry. Absolutely. It's something we've seen before. We have actually seen,
Yeah.
even some of you will be able to relate with this technology. So Saline, I think I'm very excited because this is one part that this is quite a huge burden we are going to offload from homeowners, not only through cutting costs, but also through exposure to information that will actually make them make meaningful and informed decision about their slabs.
Yep. And when we talk about cost cutting, members, we are not just talking about 20,000 shillings. We're not talking about 40,000 shillings. We're talking hundreds of thousands of shillings, depending on the size of your structure. Today, our point of reference will be, say, 130 square meters. This is like 10 meter by 13 meter, built area. Going upstairs, and even if you're not going upstairs, the built area downstairs would be 130 square meters. So that would be a point of reference. So as we speak, already begin to visualize what 10 by 13 would be in terms of square meters, not feet, in terms of square meters. The other thing we are talking about is this is so important, but that we are not just focusing on the cost saving, but we'll also be focusing on the integrity of it, because this is a matter of life and death. If your slab falls or if your slab cracks, you have lost, if not a life, maybe lives and loads of money in terms of investment. So we are keen and we are careful that whatever we say, and when we say cost cutting, we are not compromising on the integrity of your structure. That is one, because I know there are engineers that are watching us. And so in fact, members, if you're an engineer or if you're a contractor or an experienced builder, keep asking those questions, because then it betters the content and people get to know the, substantive pieces of information through your questioning. The other item before we welcome our guest is that so we'll be talking about cost, we'll be talking about integrity, we'll be talking about efficiency and convenience, and all this would work up to what the cost cutting is in terms of time, in terms of labor. The other thing that you need to be aware of when you talk cost cutting would be expertise. Is it something that can be done locally? And we will be, somebody earlier in the day when I posted, somebody challenged and said, if you're coming here with the matter of cost cutting, you better come with a spreadsheet that shows, that demonstrates that indeed it is cost cutting, because you'd like to interrogate it. And we have done exactly that, because your word sometimes is our command. I said sometimes. Is a command. So without further ado, Mangi, do you want to welcome our guests today?
Yes, absolutely. So, hi Amos, welcome to Builders Baraza.
Hey,
hi Amos.
Yes,
hello. Hi,
good. Hello, hi Amos, welcome to Builders Baraza again. We've hosted you before actually, yes. Last year, that is not 2019. Still about flooring. Yeah, yes. Pleasure to have you again tonight.
Asanteni sana.
Yeah, really Amos, you're very welcome. Amos is the CEO for Floor Decor, and Amos has been doing, floor finishing, the beauty, what you see when you eventually, you're done. But he's taken it a notch back, or a notch back. I think that's good English. And now gone into the structural part. Excuse me if it's not good English, you get me. So he's gone to the structural part, and this is extremely important. And when Amos briefed us about this new project that he is on, new program or new product that he's producing, we were very intrigued. We visited his site. He's actually building, and he's used that very technology. For me, that's a stamp of authenticity. If somebody is willing to put their product in, where it will affect their own families, we felt that is a good thing. And so we thought it's a good thing to invite Amos again. So, sir, you're welcome.
I'm very happy to be here with you guys. Asante sana.
Excellent. So, Mangi, shall we put this show on the road?
Yes, absolutely. I think we should kick it off. So today, Amos, I think let me just take the first question about this technology. So Amos, we've heard about BBF mostly from you, and we would like to know, as the first question, please explain to our members what is BBF and what is it used for, so that we get to know exactly what we are going to.
Good. A brief recap. Hello, members. This is Amos Kibaro of Floor Decor. Let me take you through the journey. Florideco is a company that is known for Parago, Kekambao, linoleum, composite decks, and all these floor covering. So we decided to venture in the slab business because slab is part of your floor. So before, it was Florideco coming to cover your slabs with our floor covering material. Now we are starting the journey from ground going up. So a brief recap, BBF. What is BBF? BBF means beam to beam flooring. Beam to beam flooring is we are manufacturing pre-stressed T-beams. They look like rail using a mold, and the beams is what we are using to bridge the gap between one ring beam of the house to the other ring beam of the house. And the spacing between two beams, we are filling it with a hollow block. And this hollow block has a lock that interlocks on the beam. And this is what we are calling beam-to-beam flooring.
Okay, let me take it a little back. So we are saying that the BBF is beam to beam
flooring.
Beam to beam flooring. 1. 2, it is applicable after the ring beam has been done. You know, some people call the ring beam the lintel. Some people, what are the other names for it, Mwangi? The ring beam, the lintel, what else?
Tie beam.
Yes.
Yeah.
So you're saying that it's applicable after the ring beam has been tied, right?
Exactly.
And cured.
So yes. So
Correct.
I need you to give us your houses when you've already done those ring beam, tie beam, lintel, and we come with our products to bridge on top from one room to the other, from one beam to the other beam.
Okay, Mwangi, there are some pictures you're showing that should help our members understand. So you called them pre-stressed. You called them pre-stressed T-beams. Please explain that. What is pre-stressed and why are they called T-beams?
Good question. Let me take you back about concrete. Concrete is known in 3 versions. There is a plain concrete, which is PC. There is a reinforced concrete, which is RC. And then there is pre-stressed concrete, which is PSC. Most of you know the RC. RC is a concrete that you mix with rebar, D12, D10, and then you mold on top of it. That is reinforced concrete. We have plain concrete, and then we have pre-stressed concrete. What is pre-stressed concrete? Pre-stressed concrete is the same concrete that has a special type of rebar. We call it high strength inside, which has tension inside. To mevuta na machine with a hydraulic machine, it's stressed. Imevutwa. This is how we achieve the pre-stress. During the casting, we cast this T-beam. T-beam is reli SGR. That is a T-beam. Inakaa reli kabisa. Hata SGR hiyo chuma amewekelea juu ya T-beam. So how do we produce this T-beam? We have a special machine that we use that has a mold. A mold is something that would produce a T-beam. So when you pour concrete on that mold, you end up with a T-beam. But how do we do it? We first stress those strands. The chumas, they are strands. They're not the very thick one. They are like 5 millimeter, but they are high strength. Remember, engineers, you know about this rebar being mild strength and high strength. We are using high strength rebar with a 1700 Newton millimeter squared, Nm squared. It's very strong. In layman's language, that 5 millimeter strand can vuta across 20 ton. So it's that strong. So we stress it, unavuta on the machine, on that bed. And when we acquire the strength that we want on the machine, and the machine shows us the strength, we then pour concrete, which is not just a regular concrete. It's concrete in class M60. M60 Ninini. This concrete that you see the Chinese using to make bridge, it's very strong. You've seen those small molds on Wayaki where ukigonga nagari na bomoka. That is concrete in a very high class. So we put that class 60 concrete on the mold, and we wait for 18 hours for concrete to cure, and then we release the stress on the strands, on the rebar strands. So automatically, when you release the stress on those strands, they will tend to go back to their original formats. And
they attempt to do so.
they actually go at very high speed. They go back to where they're supposed to be at the original space. But when they go there, they don't find that space anymore because the concrete has occupied. So members, I need you to understand, when that rebar high strength steel goes back to its original format, if you did shortcut simiti kidogo ukacheza hivi, and this rebar is going back at very high speed, that concrete would crack immediately. So you're not going to have that product in the market. So there's no shortcut there.
All right.
So there's no shortcut. So when
and
we
in here,
yes.
Sorry, Amos.
Yes.
In here, I need you to say early in the day, is there any metal? Is there any steel inside this thing?
The steel is one we are stressing. We have a machine.
Okay.
We put strands in one mold, and then we stress. And when you stress, you pour concrete on it, and you wait 18 hours. The concrete is started to cure, and then we come and release the stress with we tell the machine to release the stress. Then that strand will go back to its original format. And when they go back, they don't find anywhere to go back. So they end up being stressed. So you create a product which is very high tensile with a lot of strength, which is load bearing. Actually, the T-beam, when you get it out of the mold, we call demolding. When you remove it from the mold, it comes imejikunja, ready for action. And this is what we are calling T-beam. This is the raw material.
Okay, so for members who joined us about 2 or 3 minutes after we began, we are talking about beam-to-beam flooring, which is a replacement of the regular slab that you put on your first floor before you actually do your first floor or second floor walling. And it is, there are bars that you put beam to beam, across, so that, and Amos will be taking us through how to now finish it so that it is ready for tiling and for stuff like that. Yeah. So, Amos, perhaps you tell us what is the origin of this technology? Where has it been used before? And is it here now? Is it in Kenya now? Can we actually access it?
Well, pre-stressing concrete was invented in 1886, but it became popular in the 1886. 1886, the slavery, when the slave trade ended, I think 1886, right about there. 1886.
Okay.
And it became popular in the 1950s in Europe. And this is when Europe was rebuilding after the First or the Second World War. And this is when they went back to the 1886 technology and they started rebuilding Europe using pre-stressed concrete. It's very popular in California. Yeah. So it's been there. And a very good recap is what is happening in our country since the Chinese started building our roads. You've seen the bridges. You've seen, like now with the airport road, you can see what is happening with the pre-stressed concrete.
Excellent. So is it now here? Is it in Africa? Is it in Kenya? Can we access it?
Yes, it is in Kenya. It's been in Kenya for a couple of years now, maybe since 2015. Okay. But I think the awareness level was not that much. I mean, the people doing huge projects used to use it, so it was more reserved for projects. And now here we are using it for builders who are building every day. It's not reserved for the project. It's a product that can be used by everyone.
Exactly. But then the usage of it has been popularized for big projects, but now we are saying that this thing is applicable in a home building, and therefore we are bringing it home to home builders and homeowners. Mwangi, do you have any questions? Oh, Mwangi, we can't hear you. Mwangi, you're muted.
Sorry, I was on mute. So I can only give a comment. I know we were there with Amos, and he showed us the product, and I've been listening in terms of how he's manufacturing the pre-stressed beams are being manufactured, and I can't I'm just relating with the conventional way of how people do slabs, and there's a relation in terms of even in the conventional way, we still have steel. But in BBF, Amos is stressing the beam so that this comes with additional strength, durability of the slab compared to the traditional way. So I think that there is a very key component by Amos, the pre-stressing of the beam and the class of concrete that is being used. I think is an additional value to the concrete and the BBF in comparison to the conventional way that we do slabs. The other thing the other thing I noticed is concrete when mixed with rebar, usually both play different roles. Concrete is very good in compression, and then steel is very good in tensional forces. So when Amos say they are pre-stressing the beam, actually they are also strengthening the tensional, like the tolerance of the steel towards tensional forces, because when a slab is horizontal and we have vertical forces acting on it, that means pre-stressed steel will actually be much stronger than the traditional way that we do slab. So
it is true.
That's a comment I just observed from his explanation.
All right. So Amos, in Kenya, who is making the BBF? Where may we find BBF?
We are stocking this product at Floor Deco outlet countrywide. We are stocking this product.
Are you manufacturing it in Kenya?
Yes. And there are a couple more companies that are doing that already. So Floor Deco, the stock is of this product. So we are stocking this product to our customers, our existing customers, because it has a huge base for the awareness level.
Good. So you're saying that you're not just stocking it, you're manufacturing it and stocking it in all your outlets.
Yes.
Excellent. All right. Now tell us, in the building journey, Amos, in the building journey, what problem or what challenges does the BBF product help with? What challenges does it address? Inatuondolea shida gani?
It addresses a lot of challenges when you're at not only on the slab level. Let's start from the ground level. We have problem with black cotton soil. You want to suspend a foundation. The BBF comes very handy for such scenarios on the foundation level. When you go to first floor, BBF, it's a quick way to finish your slab. Remember, with the traditional way, there's 21 days. You have to prop your structure with timber and create formwork. BBF eliminates all that, no steel on site, and use very little cement. And you can do this within hours. And then you don't have to wait the 21 days. Once you assemble the BBF on your slab and you put a 15mm concrete top, the following day you continue plastering downstairs as you lay the bricks up.
So you're saying that because you have already pre-stressed and produced the T-beams, on my site, I do not need to buy any more steel.
Exactly, because I'm bringing you a ready-to-use product, assembled. So we just bring it to your site.
It's assembled.
Yes.
So beyond the T-beams, I also need the hollow blocks. And then you're saying that after that, I will just need 50mm of concrete.
Yes, to top it up, to make that floor.
What is the nature of this concrete? Is it cement only, or is it cement and sand?
It's called PC, plain concrete. Plain concrete doesn't have any rebar in it. And we're using 6 to 9mm of ballast, kokoto. You just mix with cement with the right ratio. And then again, you don't need to put that BRC, the BRC mesh on top. You just use fiber, Sika fiber, to make that concrete not to crack in the future, to make it crack free. Fiber does a very good job on that.
Excellent. So then the other thing, just so that I'm sure that we are ticking the boxes, you are saying that rather than treat or cure my my slab for 21 days with the water every day, how long do I need after I have put the precast T-beams, BBF, before I can put the 50mm concrete?
Immediately, we come in the morning, we assemble the beams and the hollow blocks. In the afternoon, you're ready. You add concrete on it, and you're done. And the best way to do the concrete now, go to the premix guy. They're selling this product for 10,000 shillings per cubic meter. You just pour, and you're done within hours.
I see. So it's after after the 50-millimeter layer of concrete above the T-beam has been done, how long can I wait, or must I wait before I can start doing my walling?
You can start right immediately tomorrow, the following day, and just pour. Concrete would compress immediately within 10 hours. So start doing your walling the following day as you pour water every day for 4 days. When
okay, so as I do my walling, I continue curing my floor.
Yes, it will cure within 4 days.
Wow. So members, listen, usually, Mwangi, how long does it take to cure a slab in the traditional way? You are muted, sir.
Sorry, that's 21 to 28 days.
21 to 28 days. And here we are talking about a slab for home. You know, it's not a slab for some institution or a bridge or something like that. We are talking about a slab for home, you know. So you are going to be saving a whole, look at that picture, members. You see it is beam to beam. You see in between they put the hollow blocks, and it's got an interlocking sort of technology, so that, you know, once they are locked in there, they do not move. However, because they are pieces, you see the space in between, and that's the reason why you would have to put that concrete and actually get a vibrator there to really vibrate it properly, so that, you know, there are no pockets there. Do you want to say something about that, Amos? Because Mwangi has shown us the picture.
yeah, you use a power screed, which is I had an image or a video I sent earlier with power screed. Which is once you pour the concrete, you use the power screed to vibrate. Vibration removes any air bubble in the concrete. If you don't vibrate your concrete, it will dry with some spaces, and that spaces will crack. It will look horrible. So you have to vibrate to remove any air bubble inside the concrete for it to cure with 0 air pockets. And this is the reason we vibrate.
Excellent. So the vibration is extremely important, especially if you know, for any slab, usually you would want to do that to expel any air pockets or any pockets there that, you know, will not be filled properly if you don't vibrate, because then it will make your, you know, then it compromises on the integrity of your slab and it could crack. Yeah, Mwangi, anything else before we move to cost? Because I know a lot of people are waiting to see what cost saving there is here.
I think Amos, maybe we could ask Amos to explain further, because he talked about application of BBF for flooring in areas that have cotton soil. So I know
it's black cotton soil.
Yeah, sorry, black cotton soil. So I don't know, Amos, do you want to like expound further? Because I know this is an area whereby most people will actually get to benefit a lot, because in cotton, where we have black cotton soils, usually you have to excavate the whole of that black cotton soil, or you have like to use suspended beam technology, which actually all of them are very expensive. Either way, whichever you use, it's very expensive. Amos, do you want perhaps to explain further on black cotton soils areas?
Yes. Members, you need to understand why black cotton soil is excavated from your side, the top layer of the black cotton soil. There are 2 reasons why. Black cotton soil in its nature expands. And if it expand under your slab, it's good to crack it. I once witnessed a situation where I went to visit someone and I was trying to open the door, and the door was not opening because the black cotton under the house was not well excavated. So it expanded, and it's just a nature way of it expanding. The second issue with the black cotton soil is retaining of water. We as floor deck, we go to locations where there's this black cotton soil, like Biko, Ruai, Kamulu, there's so many places. And if the black cotton soil is not well done, we experience problem with our floor covering, getting the moisture. You see the water swelling, and it's a lot of water. So BBF is a solution that is going to cut your cost down if you're building that black cotton soil. You know, black cotton soil areas at a plot hazina bei. Plot maguta hizo uko wanauza because they sell them like that because people are scared of the excavation of soil because it's a tedious and expensive process. So working with your engineer, we as floor decor, we work closely with your engineer. So an engineer is someone who has a lot of knowledge on how to handle a suspended foundation. So he's going to recommend the right rebar for the RC. So an engineer or a geologist is supposed to come and check where the rock level on that black soil is located. There are certain ways they can check on that. Once the geologist or the engineer satisfy where the rock is, then they give you the go-ahead to just dig the column. Mtaro ya column tu, shimo tu, vile column itaenda huko chini ifikie rock. Let me
so the column must reach the rock.
Yes,
the column must reach the rock. It's important for members to know that it is floating, but the structural part, which is the column, must go down to the rock.
Yes, the structural column must reach the rock. And if you don't find the rock, because there's some situation where you don't find the rock, an engineer should introduce a big footing, a big slab, kimugu kikubwa, kinakorogewa, kimugu kia nyumba. And an engineer is supposed to specify how big that footing should be if you don't find the rock. Let me give you a typical example, members. You've seen the Chinese building a section on where they were demolishing those bridges. Every day I would see them digging a borehole. I used to wonder what a borehole is being dug on Waiakiwe. Then I came to find out that is not a borehole. They had a special machine that was going down to find the rock, and at some point encountering water. And once they get that, then they come and write a report and say they found the rock and this is where the bridge footing would go to. This is the same thing with any structure. Nyumba ni column, and your column lazima ikalie mahali kule chini. It's either rock, it's not rock, then you have to introduce a big footing. Now, come to BBF. Once you found your way out, you need to introduce the columns. Maybe your space is like 50 by 100. You have to space those columns to our spans. You know, a BBF rarely saw spans. We don't go very long spans. The maximum we can go is 7. And if you're going at 7, we must introduce like 3 beams at a go together. So once you dig the columns, let them come up above the ground. Make sure there is a ground clearance of about where the engineer would specify where you're very secure from the black cotton soil. And this is when they're above and they're clear from the black cotton soil, then you introduce something called ground beams. So those ground beams will go interconnecting all those beams that are now up. And once you have those ground beams interconnecting, then we come lay the BBF on top. This is happening, but in a way, in a traditional way already. What we are seeing, they are suspended foundation, but they use timber to prop them. And then when you're done putting them with timber, then you cannot remove that timber again. So in a rot. There are other suspended ones that I've seen. Yeah, there are other suspended ones that I've seen where they excavate kidogo soil and then they backfill it with maram, and then they suspend a slab on that maram. That is what is there in the market. The other one is just excavating that soil, which is expensive. The dumping cost, the kanjo fees, the truck cost, it's an expensive affair. With BBF, we are saving you all that headache, and you can do your foundation within a week. And
excellent, because anyway, the precast are strong and they're already pre-stressed. Yeah. So Mwangi, perhaps you want to show us that picture again and also pull out the file on costs, on comparative costs. So members, I know one of the flagship things that we mentioned about the precast, BBF flooring is that it cuts your costs by half, and it is a reality. It's probably more than half, but we choose to say half because, a lot of things are relative. It cuts the cost of labor because you use fewer days. Remember, you pay your fundis per day, and this is a job that on 130 square meters, this is a job that can actually be done within a day or two. And then the 50 millimeter concrete layer, is something that you put up in a day, you water it for 4 days, and you're watering it, by the way, as you're already building your wall. So you are reducing the number of days and therefore reducing the cost of labor, as well as time, as I've already explained. But the other thing is about convenience. You know how the city plots are, where your neighbor is building and you're building and somebody across is building and you're wondering, okay, where do I even put my ballast when the lorry comes? Where do I put my sand? Where do I put my steel bars when they come? You know, how do I store them so that, you know, the site house must really be, you know, strong, because it's containing a lot of valuable things, and that is another cost. So for precast, you know, pre-stressed BBF, they bring that already in a precast sort of bar or T-beam or what we are calling the BBF, you know, that's already there. So it saves you all that. It is quick, it is convenient. You do not have to wait for you know, to find a place to even put all these materials that I have spoken about. However, you will need storage for them, because it might take a day or two to actually, you know, lay them on your rooms. So even if they're outside or they're inside the house with no roof, and you get an askari to watch over it for 2 days, after 2 days it's already been set up, and so the askari can go. So it already saves you a lot of costs, you know, in that regard. So Mwangi, you probably want to show us the comparative cost between the traditional slabbing and the BBF flooring, the BB flooring or BBF floor casts. Mwangi? Mwangi, are you here? Are you muted again? Moses Wi-Fi Mwangi. Okay, members, while you wait for Mwangi, you probably want to get a paper and pen, because Amos can actually read this out for us. Oh, there it is. It's coming up on your screen. Mwangi, you want to show that to us? Members, you may take a pen and paper just so that, you know, you can actually write this down, and you can challenge us on it later, because if there is any cost you think we have put there or that we haven't put in there that you think is necessary, let us include it, so that, you know, we are telling you things that are real. When we say 50%, we mean 50% or more, nothing less. Mwangi, are you able to? Oh, great. So members, there it is. This is the cost of doing this. So the top, I'll explain this chart or this this Excel sheet. Here, our point of reference, as I had mentioned, is 130 square meters. That is 13 by 10, a house that is 13 by 10 downstairs and upstairs. So downstairs will be 130 and upstairs will be 130. So the items that you require for that, and this is a very close approximation, you need D10s, and for that you need 270 pieces. D10, for those who do not know, is the kind of steel that you need for a slab. Per unit cost currently is 970, and so it brings it, you know, look at the totals at the end. Then you need D8, you need D12, and the pieces are there, you know, and the total cost across. You need timber, and timber is required for formwork. You know, Amos, I don't know, I don't see, maybe, okay, there are trappers here, exactly. Mwangi, go slow. Yeah. You need posts, you know, those round poles, you know, that you buy so that your formwork is propped up. Yeah, you need like 100. You need like 100 of those. You need ballast, you need sand, you need cement. You need 150 bags for this kind of, you know, for this size of slab. Assuming that each is 550, assuming Bamburi brings it to site, it will be about 550. And then there is labor. Then there is this steel fixing, you know, how you tie them across so that, you know, they can go onto your slab. And you also need water, and this water is for mixing the concrete, and it is also for, you know, for curing later. Now the total cost of this slab is 1.082400. Mwangi, am I reading right?
That's correct. That's 1,082,400.
And that is for a slab for a house that is 10 by 13, which is 130 thereabout. You know, it could be 5 by 62 by 62 by 26, but yeah. I mean 10 by 13 is average. So the cost comes to 1.082, you know, million. Yeah. Any cost there that you see that we have exaggerated, you know, tell us in the in the comment section so that we can correct it later, but we cross-check this. You need trappers. This is the one that is done sometimes with the marine boards, you know, that all that foam work and finishing so that, you know, you're having a smooth finish. By the time you remove that timber, your slab remains sturdy. A lot of time is taken to just tie the steel bars together so that it runs across, you know, before they actually put concrete and do the vibration itself, you know. So that is 1.082. Say 1.1 approximately. Wangi, do you want to show us what this exact house would cost to slab using the BBF? Wangi, do you want to explain it?
I think this one, Amos should take it. He's the
Amos, go ahead.
Yeah.
Okay. You need 130 square meter of the beam to beam, including the hollow blocks. We sell this product at 3,200 per square meter. So the railing and the hollow block alone is 416,000 members. We need to cover the product, the beam to beam floor. You need to cover with a 50 millimeter concrete topping. Remember I told you about the concrete topping with the fiber mix?
The 50 millimeters, yes.
Yes, and it's costing 700 shillings per square meter, and this is labor included. That is 1,000, labor included.
Did you say this is labor included?
Yes, for 700 shillings per square meter of 130 for the concrete, the 50 millimeter. Cement, ballast, maji, koroga.
Okay.
Installation of assembling the BBF. You need to assemble. Remember, 1 meter of the railing is 24 kilograms. We need 10 hollow blocks for a square meter, and 1 square meter weighs 222 kilograms. Very well calculated mathematics. Remember, when using the BBF kind of system, you have calculated mathematics, no shortcuts. Hesabu ambayo inaingiana. And installation of it, we're charging 250 shillings per square meter. We connect you to an accredited installer, but we are getting a lot of backlash from the fundis on the ground, and we want to work with them. So if our client is buying the BBF, we want to work with the foreman of that site to train them how to install these products so that in the future, they just buy and go do it themselves. And we've not charged you transports. Perhaps you've seen the BBF and you visited our shop in Kisumu, for instance. We need to ship this material from Nairobi. And the transport costs would range between 30,000 to maybe 60,000. When you're doing the other traditional way, you have a lot of transport costs, the ballast, cement, so many. This is one of. And the total for this is 533,000. This translates to
okay, members,
50%.
This is where we clap because it is indeed half.
Absolutely, yes.
Yeah. So you're saying that without transport, because even in the previous, you know, spreadsheet, we did not have transport costs there. So we are comparing like to like with the same level of strength, if not stronger with BBF. Between the comparison is 1.082 million to 533, and we're getting the same sort of you know, slab, only faster. Like in 4 days it's ready. The traditional one will take between 21 to 28 days. Not so.
Yeah, and not factoring the formwork. The formwork takes like 2 weeks.
Yes, the formwork actually takes 2 weeks before you actually put the concrete. The formwork actually takes 2 weeks. You know, to prepare all that stuff takes 2 weeks for this size of house. So really, we are talking 6 weeks, you know, for curing and for the, you know, the preparation before you actually put in the concrete in the traditional way. But with the BBF, we are talking half the cost, which is 533. We are talking convenience. We are talking about, you know, you're saving in labor. You know, if you're a fundi, this should not threaten you because it means you can do more sites within 1 month rather than stay at one site, and therefore it works out, you know, the exact same way in terms of what you can take home. So we need you to actually promote this because it is faster. It will get more people building because building is becoming affordable. It will get them to invite you to their sites, and that means that then iko kazi ni mingi, the turnaround is quicker, and you are busier and you're earning more money. So members, I hope that we have, you know, exhaustively demonstrated to you the 50% that we are talking about, that indeed it is doable to cut your cost of foundation and your cost of slab by 50% using the BBF technology. Very, very well done, Floor Decor. Very well done. Wangi, shall we go to the next question?
Yes.
And here we are talking about, you know, Amos, this one still perplexes me. I know that you have a certain mold which can produce, you know, only a certain length, you know. So what is the longest precast BBF that I can get? You know, the bar, the
Really?
precast, the T-beam. Really?
Really,
What is the longest I can get?
That really, the longest you can get is 7 meters.
Is 7 meters. So what
Yes.
happens if I want to use it in a room that is wider or longer than 7 meters? What will happen?
We work with your engineer to introduce beams to cut that room across. You all know rooms that are longer than 7 meters, we even have a column in the middle. In most places you've seen, like halls, they have a column in the middle. So with our system, we have to work with your engineer to introduce a beam that will cut a space into half. There are 2 ways that you can do that. You can use a silent beam. A silent beam is a beam that is integrated inside the thickness. Remember, guys, the T-beam and the 50 millimeter concrete, when it's applied, is 200 millimeter. Okay, it's 200 millimeter. You can introduce a H-beam steel, and the T-beam will go and latch in between, and that breaks the space. You can do this for mezzanine warehouses and typically anything. The good thing with the H-beam, it's a silent beam. So if you don't like seeing your ceiling with a hanging beam, this can be nicely incorporated. The other way is the traditional way.
Yeah.
Introduce a beam. If you introduce a beam
Yeah,
is,
so this
300.
requires your structural engineer, guys. With this technology, it does not eliminate the importance of the fundi. It does not eliminate the importance of the building professionals along your path. You know, your building path, like the engineers, very, very important. And so if you're going to be using this BBF, you better, you know, just know it's not a shortcut. It is a cost-cutting, you know, way without compromising on the integrity. So Emma says that the longest really you can get is 7 meters. However, if your room is bigger, usually if the room is much bigger, even in the traditional way, you would usually have a pillar, you know. And so this is the same pillar that we're referring to, so that, you know, you can have 2 of these beams across, you know, your room. However, assuming my room is 12 meters wide or 12 feet, yeah? Is it in feet or meters, this thing you're saying?
Meters.
It's meters. So if my room is 12 meters, it means that you can get for me a 7 meter railing, but you can also get for me a 5 meter railing, as in you can customize it to suit my room.
Exactly.
Yeah. Okay, members. Monkey, do you want to ask the next question? Like, you know, the weight per square meter? Yeah.
Yeah, so before we go to the next question, I think we just have clarified a question by one of the members asking if this technology is viable for shorter spans. Apparently he have heard that it only makes sense when building large slab spans like churches and malls. So I think this question has been well tackled. So yes, so to answer your question, yes, this technology can actually be used even for shorter slab spans.
It's probably stronger even with the shorter, you know, because there is no column in between. So it is beam to beam indeed.
Yes.
Yeah. On our website at www.floordecorkenya.com, we have a downloadable specs, the specification for an engineer to work with. So you go to the website, go to the beam to beam flooring section, and just download that schedule. It gives you all the information that you need to know.
Excellent. All right. So one of the things, Amos, when we visited your site that really got me thinking is, okay, I want to know the strength of this slab on my first floor, the strength of this slab per square meter. How much weight can sit on it successfully with no threat per square meter?
Good. We measure that in the engineer's term per kilonewton, KN. 1 kilonewton is 100 kilograms. So kilonewton determines the span of the beam. We have this sheet on our website, but I'll briefly take you through, guys. We are working with 2.5 kilonewton. That is an average of 250 kilograms, assuming 2 adults standing on a square meter area that they are moving a dynamic weight can hold at least 250 to 300 kilograms. And this is mostly for residential houses, our homes. So with 2.5 kilonewton, we can span averagely up to 7 meters. But the schedules shows us how we can introduce 2 beams, 3 beams at a time to support the weight. But on the standard 1 hollow block, 1 beam, you can do up to 3.5 meters. Most bedrooms are 3.5 by, let's say, 4. We go to the shortest span. So if you have a bedroom of 4.5 by 3.5, definitely our beam to beam flooring is going to go to the shortest span.
Okay. Yeah. All right. Okay. So our next questions had been answered. Like why the benefits of this, over a regular suspended foundation. That one we've already, tackled very, very exhaustively. Mwangi, maybe the question number 14. You want to take that?
No, so on the question, I think the only one, that's one we can we can tackle at the end. But then the next question for Amos, I think I would like we can dwell into now. Also, we've talked about the pre-stressed beam. Amos, maybe let's talk now about what else do I need alongside the pre-stressed beams. So let's talk about all that. That hollow block. Let's talk about everything else we need for this floor.
Our system is a beam ready and a hollow block, so that is a complete system. The only additional that happens at the site is a 50mm concrete topping, which yes, we do it at the site. So the hollow yes, block is specially made. If you look at the hollow block that we have for this system, they're interlocking on the railing. They go enlarge. They interlock actually, very strong. When you see them underneath, like your downstairs and looking at the system, it's beautiful, it's awesome. You may never need to plaster it, and you just leave it like that. If you have rustic design, the concrete is beautiful. So the hollow block is well professionally done. With the hollow block is simple. We do with the egla, you mix with cement and with the right ratio, and you get the hollow block. So the hollow block is a component of the T-beam.
Okay, now maybe you can expound on how strong are they given now. This is a slab, so yes, especially when we come to finishing and interiors, these guys usually have to drill into the slab. They have to mount stuff into the slab. Let's discuss how strong they are to support any additional or mounting on the wall, ceiling to the slab. How strong are they, or how durable are they?
If you want to mount anything very heavy, you can always drill a section of a T-beam. A T-beam, remember, is pre-stressed, very strong. You can hold whatever, a big chandelier or whatever you want to hang on that house. The hollow block itself is equally strong. It's M20, mixture of concrete, very strong. And remember, our hollow block has some tunnels. So when we are doing the installation of PBF, the plumber, the electrician are on site. So they have an easy way to run their services, the cables, the pipes, up to 4 inches of a pipe. The electricals, you want to create a bottle trap, you just drill, cut with a grinder, the hollow block, and make that hole in. Fit your accessory there. You want to do a circular junction for electricity underneath, you just cut and fit. An electrician who would enjoy working with BPF, because this simplifies their work. The pipes are safely tucked in the tunnel, so they'll never break. And those tunnels, also the hollow block, acts as vacuum. So you've seen those red clay works, the clay type one that people use. If someone is upstairs, especially in flats, the noise, if somebody's skipping a rope, the noise is so much. With BPF, that noise is history. You'll never hear that noise again because it disappears in a hollow part of the block.
Yeah,
very
I
solid.
think that's really, really important. Mwangi, perhaps you can show us a picture that will show that shows the T-beam and the hollow blocks together, because maybe members would like to see, you know, in between those, it is the hollow blocks are perforated, they're hollow, right? So what this helps in doing, it helps the plumber and the electrician in piping everything that they require. So indeed, it is not just yes, you see those 3 holes there, because they run across. And a lot of there's a lot of piping that goes into your slabbing and all, you know, for all these utilities that you require when you finish building. Those hollow blocks provide channels through which those wires and those, you know, those pipes may be put in, and it makes work pretty easy for the plumbers and the electricians. Yeah. So Amos, one thing that you have said that I'd like to reiterate is, you know, in response to what Mwangi asked, like if I have a 50 kilo chandelier that I want to hang, is it all right for me to drill through that hollow block so that, you know, my chandelier is strong in there? Or do I need to drill the, you know, the T-beam, that T-reli? And how drillable is the reli really? Because ni ngumu sana. Hiyo nitatumia ribbit gani?
Utatumia ribbit kubwa kama zile za nyayo embakasi. Utatumia tu ribbit, but drill the hollow block. It's strong enough. The concrete grade is FCU 60 kilonewton per millimeter square. I mean, this engineer will understand this. It's strong.
So you're saying that it's all right to drill the hollow block to put my chandeliers in, for instance.
Yes, use a self-tapping screws. But if your weight is extremely very heavy, then you can drill 1 T-beam, but you need to use a special diamond tip bit.
Absolutely. That's a big beat, man. Yeah, Mwangi, carry on.
Yeah, I think the last question from me would be, maybe Amos, we can go through the what to do and what not to do for you to achieve a perfect BBF flooring. So we just go through this is what, like, these are the standard that everyone or every fundi probably or contractor needs to follow for them to achieve a perfect, a very strong BBF flooring. And this is not what to do.
So the must do's and the must not do's.
Yes.
The must do, you have to build your ring beams according to the engineer's drawings and what they've recommended, the type of rebar to use for your RC, the reinforced concrete for your beams. And once you do your beams and they are well done, a standard beam is 200 millimeter. Inatoshana mawe kwenye iko chini. And they go as high as some 400. The standard is 300. So once your ring beam is up, you need to put the level on top of it. Unavuta fundi, unavuta kamba, una make sure ile beam ile side ya left, beam ya right ziko level moja. Tusiweke BBF tukapata nyumba imenema pande moja, ukiwa huko kwa bedroom unapata floor inaenda pande nyingine. So make sure once the beams are ready, the level is well done, achieved using a kamba. And if kuna pande imenema, you fill with mortar. The release, the T-beams, they latch on 100 millimeter of your ring beam. Remember, a beam is 200 millimeters. We are using a section of 100 millimeter of your beam. The other 100 millimeter is the other beam to go to the other room that will latch on it. So you're utilizing your beam. So your beam is the core thing for your BBF to work.
Which means the shortest, the thinnest my beam can be is 200 millimeters.
Yes, I have seen thin beams of 100 millimeter. Then we interlock the beams. They go interlocking because they cannot latch on 100, so they go interlocking.
Yeah, so they'll go across like that.
Yes.
That makes sense. So let me ask you, Amos, on that factor, before you tell us what more we must do or must not do, can this be used when the walls are built of brick?
The walls are just partitions. We love the bricks because they don't have a lot of weight. Remember, guys, I've seen drawings from our customers. When you look at the drawing and you're doing the ground floor, you realize the first floor going up again, some walls are now not on the beams themselves. Zinapitia huko katikati. This happens so often because we find our customers saying, this room is too small, I need to extend it a little bit. When you're extending it a little bit, that partition wall will not be on the beam. So the weight, so we have to factor the weight. Again, we are working with the engineers very well. If you see that kind of a problem, we have to recommend to use a bricks. Partition room. Use a brick, interlocking brick, which is light in weight, not to give the subfloor underneath a lot of weight. You can do drywall partition, like in the US, they do drywall partitions. Gypsum, partition your rooms. Yeah.
All right. So what else must we do?
The don'ts is that one of knowing where the partition walls on the upper surface are going. So we have to be very keen on that, so that we know what kind of material to use on a partition wall which is not aligned to the beams, to the ring beams. And the beams need to be properly done with the right rebar inside. Those two things are the most important to follow.
Okay, and tell us about vibrating it. We already said it, but you may want to reiterate it because it's important.
Yes, and before I go to the vibrating, let's talk about the Comparative. Comparative is the overhanging one. You know, you want to have an overhanging slab. Our system doesn't work with Comparative.
You mean like a bigger hood than the wall?
The balconies which are not supported underneath.
Yes. You
see the balconies? The farthest we can go is 400 millimeter. If you want to introduce a 1.5, then you need to find a way to introduce ring beams again, or just do it solid. And after the staircase, guys, after the staircase, you need to go 4 feet inside, solid again. You need to go 4 feet inside.
No, that's not clear, even to me.
You see the way the staircase is done from ground floor going up. So you have that staircase going up, and it's going to end up to our BBF flooring. It doesn't start immediately. It goes inside 4 feet, solid.
Okay, solid. Yeah.
Rebar, yes, reinforced concrete, yes. If you're going to have balconies, overhanging balconies, remember our system would not work with that. So we have to work again with the engineer to give you a solution. And most solution will be to do those balconies solid. Yes. I've seen people.
Did we lose Amos?
Yes, we just lost.
He's coming back.
He's coming back.
He's coming back.
You just need to.
Yeah, Amos, we lost you. Sorry.
Yeah. I'm back. I've seen members concerned on wet rooms, the bathrooms. The BBF system works very well. Right now, the technology has expanded. We have a lot of waterproofing product, Arcfix, Ciba, liquid membranes. You can just apply a liquid membrane and you have a waterproof area, and then you can put ceramic tiles on top. BBF system doesn't work on swimming pools. Swimming pool has to be RC, reinforced concrete solid.
Got it.
So, yeah. Let's go now to the 50 millimeter topping. We apply 50 millimeter. You can do more if you want, but 50 millimeter is not enough. The concrete mix is concrete with 6 to 9 millimeter concrete ballast size.
Ballast,
the ballast.
Ballast is kokoto, guys. The small kokoto.
Yeah, the small kokoto of 6 to 9 millimeter mix, and you mix, and then you add silica fiber to make it bond not to crack in the future. And you just apply. It. And
can we get this fiber in the regular shops, or do you have to be the one that supplies that?
Well, I know some hardwares in Nairobi do sell. It's very cheap. It's like 1,000 shillings per 1 kilogram of fiber at Luxembourg and few shops in the industrial area where we are stocking these at Florida also. Yeah.
Okay, and tell us about waterproofing. Is that what you just talked about? That's where you use because we know a lot of these slabs that are going onto the flat roofs. Is there a special fiber that you apply so that it is, waterproofed, or is it the same one that you use in the bathrooms? Tell us about waterproofing.
Now, flat roof lovers, I know members here love flat roofs, and flat roofs with BPF is a big saving. So if you have a flat roof, there are 3 ways that I would advise you to go. The first one is very basic and general. Water doesn't like to be somewhere stationary. Water needs to be always on the move. If it goes to a slab which is stationary, then we end up, the water will find its way. So with your contractor, you need to introduce water darts. At the flat roof, make sure water travels to the shortest distance to find the dart. So introduce water darts and incline the slab. When the 50mm topping, when you're doing the 50mm topping, just put a gradient for water to go. Make sure there are darts all around your surface area so that water can easily flow. And just reinforce with the concrete, just add some waterproofing cement on it and have a gradient. You'll never see water coming down to your rooms. The second way is adding the traditional way of the membrane. You know that membrane in a chomona gas. It's quite good. It works very long. But if you have traffic and a flat roof, then the UV rays, and you step on the membrane, it will crack. See, the other way is to apply a 50 or a 25mm concrete using our system and applying the liquid membrane, a fixed liquid membrane, inapakwa na roller kama paint. After you've done the 25mm, you apply the liquid membrane, apply na roller. After 4 hours, it forms a 3mm homogeneous layer, a 3mm layer on it. Once the layer is already there, apply the remaining 25mm to cover, and your slab will be forever waterproofed. You never have anything on it. You can put your slab with a tough grass, so that floor decor. You can put composite deck. It's a great place to relax.
Excellent. Yeah. Or for those people who think that they must put a tank upstairs, it is strong enough to actually hold a huge tank there, you know. I don't know how water will get there. Maybe from a borehole, you pump it upstairs. You can do it. And if you want to conceal things that are there, because as Amos has said, you know, you can have a gradient, roof, but from outside, people will see it as flat. You know, you can put that wall, what is it called? The parapet wall, so that, you know, it hides things in there. Nobody can see it. Yeah. So because we are in the last, few minutes of our show, I wanted us to talk about training. Where did you get your training to be able to manufacture this? And are you training people to be able to take this to the market, to homeowners?
We are working with the local foodies to install these products. I've seen a concern when a new technology comes, the foodies on the ground are saying, hii kitu inachukua kazi. Hii kitu ingekuwa ya chuma anafunga chuma, sasa kazi ya chuma kuna. Hii maneno watu wakoroga hawayuko kwa kazi. Technology is unstoppable, guys. And the faster we adopt it, the better. But adopt the technology. Don't say inachukua kazi yako. Just adopt it and get onto the grind. Be an installer for this product. And we are very open. When you have a site, we call you. You come and learn to install. It's very easy. You don't need any skills. You just kubeba hizo beams, kuzipanga, and then do the koroga. So we are working.
So no. With, but Amos, I need to know if you're providing any sort of training for people who would like to learn to do this, because this is important to learn. They must learn it. It can't be too easy. Kupanga too. They must learn it.
Yeah. We are working closely with the stakeholders in the industry to learn how to do the installation. Yeah, perfect. We are working as we've done with floor decor products. We always work with the team and we accredit them. So once we are selling this product, we say we have a accredited team that install this. These are the numbers to contact.
Excellent. All right. Now, and are there any buildings that are? Oh, there we go. That's a crane placing the beams. This one is using a crane.
No, this is a site where they've in the UK where they've automated this. The regular way we have, we paper it with we don't need. But if you're doing 4 or 5 floors, then you need to introduce a hoist to hoist the product from the ground to take them up. It's tedious work to carry 4 or 5 meter beam in the rooms. It's not easy.
Yeah. Yeah. More, Amos, is there any building that we already know, you know, a common building that has used this technology? Where can we see it? Where can we go and see it?
Yeah, I mean, there's so many done before us getting on board. There are so many. Some of these
Yes,
are building.
which ones, for instance?
I can only tell you what we worked on.
Okay.
Hello? I can only say what
Yes.
we worked on. We have a 5-floor building in Naivasha. Right now we are doing the one in Kikuyu, which we've been inviting guys to come and see. Where we are doing various projects in Nakuru. We are doing a very huge project here at Kamakis with about 12 units for sale. And remember, guys, this product is good for people who want to build quick. Developers with money from a bank. You're building from overseas, Komaju, unataka kujenga nyumba hapa. When you come for holiday, that 30 days or 45 days break, this is your product. So we have buildings across the country, like I mentioned, and we are doing more and more. Once you visit to Floor Decor website, or we are posting these buildings as we continue doing the product.
Okay. So, Amos, assuming I want to use this, you know, there are a number of people who are just at the brink of slabbing or, you know, of laying a foundation and then black cotton soil, and they're thinking this is a solution. How can they get it? How do they reach you to be able to go? What is the process? You go to their site, they call you, you deliver. How do you do this, and how long will it take?
You call us at Floor Decor. Our numbers are, you can Google. It's a very easy number. We're countrywide, in 11 locations countrywide. You first send us your drawings. We work with your drawings, and then you tell us the intention, and then we'll send our engineer on site to have a look and give you an advice on the way forward. So we work only with drawings. You don't send us photos. You don't send us images of 3D of your buildings. No, only drawings, structural and architectural, both structural and architectural. We need those to our emails.
Structural and architectural.
Yes.
Drawings are what you need. But now sometimes there is a structural or architectural drawing, but as I build, I've moved the partitioning wall maybe 30 centimeters or 1 meter, because it happens a lot, you know.
Yes,
so what happens in that case? Because it may be that my current room is 1 meter wider than the structural, you know, drawing or architectural drawing. So what happens?
We basically need to redraw that. Remember the cases I was telling you about, having partition wall not aligning on the beams. We need to redraw them with the architect and give you a solution for that. In most cases, we need you to do the partition wall with a lighter material, with the blocks that are lighter materials.
Yeah. So members, it's important that when you're going for a quote or when you're calling for a quote, you already have the size of rooms, which is final. They will visit and they'll give you a quote. To reach Floor Decor for this BBF technology, please visit their website. There are 11 locations in this country, so it's a bit hard to be able to, you know, to list them now. But if you go to their site, you will see the number. If you're in Western, they have Kisumu. I think you have an office and you know, a showroom in Meru. Do you not?
Nanyuki, Embu, Kisii, Mombasa, Embu, Thika, Nairobi, Machakos, all these locations are on our website.
So really, the network is great. Machakos, Embu, Kisii, Meru, Kisumu, Mombasa, Nairobi, Nanyuki, you know, all those places. You'll see all the numbers there, and they will reach you and be able to give you the exact estimation. Amos, from the time I call to the time you give me an estimate, how long does it take, or to the time you deliver to me on site, assuming I have money and I can afford it?
We give you an estimate within 2 days. If there are drawings that need to be done, that may take long, because as you mentioned, people change all the time. We need a drawing to show the changes. Production takes 4 days. So once it's paid, up to 4 days, we will produce the beams.
So guys, so from the time that you pay the money, you need a total of, say, 7 days from the time you order to the time your slab is ready. Believe it or not. Is that not the case? Because you need 2 days, and ordering takes 4 days, and assuming no, not ordering, like manufacturing takes 4 days, and then I'm giving it another 1 day, say for delivering on site, you know. So if they deliver and fundis are ready, another say 2 days, and your slab is ready. But one thing, guys, that we did not mention that I think is very important is in what status, Amos, does the BBF technology leave my floor? Does it leave me ready to now do the, you know, the tiling, or do I still need to hack it or fill it? In what condition does it leave my floor?
Leave it in a perfect condition, because we are the floor people, we have so much problem in this country finding an even floor. BBF solution give you a well-leveled, perfect floor. You might only need to add a small self-leveling compound to make it smooth, perhaps. And we encourage the foremans, fundis on the site, to always have their customer site clean. Ukikoroga, unatoa hiyo koroga. Kwanza nyinyi watu wa kuweka tiles, mnakujanga mnakorogea hapo nje, mnaacha hiyo mota hapo inakauka. Those are the things that we need to look. Make sure you have a neat, clean site. Don't koroga here and leave that koroga there to form a hill.
Exactly. So guys, it leaves, I have seen, and the reason I asked this question is I've been to a site where this is used, and by the time they were done and they had put the 50 millimeter, you know, concrete after the, you know, the BBF, it was so like almost final. It's like the floor is ready to actually receive those tiles. It is actually livable. If you want to postpone the putting, you know, up of your tiling or of your flooring, you can actually move into that house. You can paint and move into that house if you must paint, and save even more money because it leaves your floor. They use that thing called the helicopter, you know, and the helicopter comes with something that is flat like a tray that just rubs it and removes anything extra and leaves it really, 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 really in good shape, you know, very close to the final Nero floor, you know, very close, and I'm being honest about this. So this is another way again of saving money, and this is why we say 50% really is a reality when you're using the BBF technology. Mwangi, I can't see you.
Yeah, I'm here and I'm following.
Yes, do you want to conclude for us, because we have actually come to the tail end of this show? Do you want to conclude for us, please?
Yeah, yes, absolutely. Amos, thank you very much for being with us tonight on Builders Baraza. We've quite learned a lot, and I know we're also going to learn about BBF in the coming.
Your Wi-Fi is hungry. Inavuta.
Oh, but can you hear me?
So I guess Mwangi is coming back on, but you know, Amos, we want to take the opportunity to thank you very much for creating time to come and educate our members on the new technology, on how to save money, and yet have the integrity of a proper slab. You know, if we have any questions, members will be listing them down here. Please be gracious enough to respond to them. Mwangi, you're back. Shall I give it back to you?
Okay, I've been listening and I've been following through. Can you hear me now?
Yeah.
Okay, I was just telling Amos how grateful we are to have him here, and to always being an active member of the community and contributing so much towards construction. So we are grateful to have you. We're also looking forward to the next few weeks to learn more about BBF. It's actually something I'm personally interested in. I've learned a lot in the previous week, so I'm also looking forward to learn more about BBF, because I know we are activists for affordable housing, because we want members in our community to be able to afford homes, be able to save towards building, and your solution that you've brought to this process is actually very vital and very important for our members, because I know they'll be able to save. For a person who was saving to build now, for example, in 3 years, seeing that they can actually save 50%, that means they can actually build in 2 years. That is much earlier than they anticipated. So this is good.
It is true, Mwangi. You know, the plot that was that if assuming the foundation and the slab, you know, that would be 2.16 million going by the math that we did, and now we are saying that it will cost you 1 million, which means there's a 1.6 that you can use to do the roofing. You know, madoido zote, you can buy more expensive fittings because you have saved, or you can just save the money. Upumzike nayo.
Yeah,
Mwangi, back to you. Yeah.
Absolutely. So the other thing I'm looking forward is, I know we want to adopt this into the affordable housing mantra in Kenya. And I know, Amos, you are going to play a very key role here in terms of providing and provision, training, everything towards this flooring system. Because the other, I think, maybe we didn't get a chance to discuss about other advantages that actually it brings to. You see the precision, Amos talked about the precision to which BBF, once it's complete, the precision in terms of accuracy and levels, that actually saves a lot when it comes to tiling. Because the other thing we usually found, these are things that are actually hidden. No homeowner will ever know, or will ever know about a contractor or something, because people hide it there. But a poorly done floor is actually very expensive when it comes to tiling, because you miss that level by, say, 20 millimeters, and you have like to do another screeding the whole floor, so that attain just a 20 mm. Yeah, so for your tiles to actually be very, very on level. So I know BBF.
For hacking.
Yes, absolutely. Yeah, so BBF actually solves this, and this is a huge cost. It's usually hidden costs that are very expensive. No homeowner knows. What they only hear from the fundi is, oh, hapa kuna kitu ilikuwa inahitajika, na hii kuwa hivi. Haambiwi haifai kuwa hivi. Anaambiwa hii kuwa hivi, lazima anga tunaweka ice cream. It's not necessary, because you see some houses and you see the thickness ya slab 200 mm, and you wonder what happened here. 210, 200. You see, a slab 150 is just enough for a residential house.
Yeah.
So these are some of the things I think BPF in Abuja to solve at a much lower.
Absolutely.
Yes. So thank you, Sana Amos, for this solution. It's something we welcome into this space.
Yes, and remember, guys, we have a KCB, Pata Flow, Lipa Pole Pole. You can get financed by KCB. We are working with Standard to come on board also. We are working with so many banks to finance this product, and you can pay easily. You're probably stuck kwa slab, nyumba inanyesha inaharibika. Go to KCB, they will finance you to cover that, and you can pay pole pole.
Excellent, guys. As Mwangi says, we really do. Our mantra here is affordable housing, that everybody should build something, even a toilet, even a balcony, even a cow shed. We support you by providing you with information around technology, how to cost save. We bargain for deals for you just so that you can realize your dream, and we appreciate your support as well. We appreciate your patronage, and we appreciate your participation here. Amos, thank you very much. Keep helping us with this, maneuvers that will help us, be homeowners sooner rather than later. So I guess we bring this to a halt. Members, thank you for patronizing. Thank you for listening to us. We hope your projects are going on well. Keep on track and keep building. Have a good weekend, and God bless you.
Yeah, you too. Have a great one. Yes. All right. Bye. Have a good evening.
Bye.